One's on, that one's on. Okay, good morning, afternoon, evening. Today we're going to look at the TD-3 from Behringer. This is a TD-3 SR, which is a silver color one. They have it in different colors. It's essentially, if you don't know, a remake of a synthesizer from the 80s that was supposed to be a bass guitar in a box. It was discontinued after about 3 years, and it turned out to be better for doing drugs with. Anyway, we're just going to focus on this in isolation. In the box here, we've got some stickers, no manual, which was interesting, just some foam, power supplies in a little box, and that's it. And then on the outside of the box, there's really not much going on. I noticed there's no website address. There is a QR code. Here we've got a little sticker saying this is the 120 volt version, the US version. Designed in Italy, made in China. Pretty minimal unit retails for about 150 bucks. I think the official retail price is a little higher than that, but this is it, and this is the power supply that came with it. It was very interesting. I found that it was it's a TC Electronic mark on the power supply, and this is the US version, so it has this adapter. 9 volts, little barrel connector, very standard, would fit into, it's probably the same power supply by the specifications as the original, would fit into a lot of setups pretty easily that way. Looking at the outside, it's a pretty light box. It's got a little bit of weight to it, which is nice, but pretty light, plasticky, sort of like the original. Yeah, the throw on the switches is very small, so they click, which is nice. They're not like, gooey or anything. There's not a lot of up and down. You can barely even feel the click to it. They're not super cheap. Nothing about it really even feels hollow. It feels pretty solid. I noticed right here on the front lip, you can kind of see, it looks straight, but you can kind of see maybe the edges of the mold or whatever, where it was made. It kind of comes together awkwardly. We'll take a look at that when we get it apart, in terms of how that goes together. Typical stationary power switch. Probably your problems in 10 years would be around here in terms of either this barrel connector or this power switch. We'll have to look and see if there's anything else that's suspect on the inside. Interestingly, here it says designed and engineered in the UK, which last time I checked, Italy was not in the UK, but maybe they mean the box was designed in Italy, I don't know. First things first, in getting this apart, we're going to want to take out the screws off the back panel. It looks like it just basically is in 2 pieces. Nice to put something lumpy down so that you don't break any knobs or put any undue stress on the front of it. Put it down like this. We've got, looks like 8 screw holes. This is a number 1 Phillips head. I don't know that these are Phillips or if they're JIS screws, but either way, as long as I'm careful, that should work. Okay, a little bit of pressure going down and comes loose, and that's good. I don't think the screwdriver is magnetic, so I'll just shake it out. Okay, here we go. It's a pointy screw with coarse threads. I'll show it to you under the microscope as well. Yeah, you get the idea. Very coarse threads. You've got a little chunk of plastic in there that's been pulled out of the screw hole. The only thing to be aware of with this, and I'll turn the microscope off. The only thing to be aware of with this is, even just with a screwdriver and using your hand, you could totally just turn it too hard in the wrong direction. Of course, if you ruin one, you're okay. You've got 7 other connections that would still work. I'll put these over here. Just so I don't have to wait around, I'm going to use a drill. Be sure to set the clutch on it so that it's really weak. This is weak enough that I can in fact just hold it still and it won't turn. And that's because it's on the 5 setting. It has even weaker settings. And this will keep it from trying too hard, because if this thing gave it full power, it would totally ruin the screw and the screw hole too. Okay, that should be all of them. Turn it over. Squeeze that out. All right, and that's all 7 of them that were left. I'll collect those. Okay. If there's nothing else attached, this back should just come right off. And it does. All right, first thing we notice is we have kind of a silver finish on the outside here. This piece we'll probably just put to the side. This is just a molded piece. There's a little bit of a lip here as the way it mates with this piece. You know, a few millimeters of a tooth to kind of line it up, but that's it. That's kind of all there is to this. I'm really glad that these rubber shoes were not over the screws. Sometimes, you know, on devices, they'll put the rubber foot right over a screw hole, which is annoying because then you have to peel that off. And anyway, here's a circuit board. I noticed in the light, the first thing I noticed, and I don't know if this is going to get picked up on the camera or not, but the first thing I noticed here is that there's quite a bit of residue. Quite a bit of residue on this board. You see some through-hole components coming through here, and of course there are some through-hole components on this side too. I guess that's just flux or some kind of wash or something. I'm not really familiar with the process. Okay, if we touch this, it doesn't seem wet. I mean, it certainly was at some point. It's totally dried out now. It just wasn't, I guess it just wasn't washed off fully. Some of these leads here are not clipped flush with the board, but I mean, who cares really? I've seen some pictures of the TD-3 on the inside and the rolling unit, and it's all through-hole components. There's multiple boards. It's cram-packed in there. There's tons of room here. In fact, some of the pins on, I guess these are chips or, no, they're probably potentiometers or switches. Some of these leads are not clipped at all. Totally just a piece was put through the hole, soldered, and that was it. Take a look at this marking from Behringer here. This is a P0DTD. PCB number, revision number. This is the first revision, I guess, looks like. The date code looks like maybe March of 2019. I don't think that can be right. Maybe it's 19th year, 38th week or something. I don't know. I imagine it's a date code. I don't know for sure. ROHS compliant, supposedly. Okay, cool. We've got 2 trim pots here. OSC scale, OSC offset. You just put a little screwdriver in there to turn those. I wouldn't do it without knowing what you're doing. You probably want to be listening to the audio as you're setting that stuff. Just like an old analog sense from the 80s. You've got trim pots for that kind of stuff. I see another one here. Let's see. I see another one here. VCF offset, VCA balance. Essentially, you just got a little cutaway in the circuit board, and you can put a screwdriver through there and adjust those pots. They're mounted on the other side. Let's see. There's also a jumper up here. Yeah, there's this too. I don't know. I'm not sure what this is. That'll be very interesting to figure out if those are for debugging. It really looks like something should be mounted there. There's not a lot of room directly across from that. It would be right under this. It would be right under the switch if it were meant to come through. But we'll have to figure out what those are later. But yeah, there's these 5, and then there's this header here that also has 5. Now, I imagine you wouldn't have to do a firmware upgrade through these. You could do a firmware upgrade through the USB, but of course, if you didn't have the USB functionality and you needed to do like JTAG and flash the firmware that way or whatever, you could do it through here. Let's see if there's anything else that seems not used on this side. Oh, here you see the label for, this is TP2 probably, and TP1. There's probably test point 1, test point 2. There's test point 4, test point 5. It'll be fun to see what those are. You probably would use a meter and hit those test points with the ground of the audio circuit to adjust the potentiometers. We'll have to figure out what that is later. It's not mentioned in the manual. That's pretty much it. It looks like the entire synthesizer is basically just on this board. It looks like it's going to be just one piece. We've got some black pieces coming through the bottom here. Interesting. Usually through-hole mounted stuff is just soldered to the board. Whatever that is clipped on through 4 holes. I'm thinking usually problems with old synths are right here, and that would be the same with this one. Not much can go wrong here except for just breaking the whole thing in half. Okay, so to do more than this, we're going to need to pull these knobs off of the front because the components are soldered to the board. So we'll start doing that. Pretty tough. I'll go ahead and turn these all down counterclockwise. Now we've got all of those off. Well, the first thing that stands out to me is the way these are mounted. They're relying on the solder connections on the bottom, which we saw. There are quite a few of them, so they're okay. But there's no washer or nut on this holding this to the surface. So it's something you want to look out for. If this was attached with a little nut, you'd want to take that off too. These are all exactly the same, I think. Yeah, these are all exactly the same height, but interestingly, one of these has a little notch in it, like this. It has the same radius, turning radius, or degree of turning as the rest of them, but it looks different, which is interesting. So again, same thing with this side. This time we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 screws. Same deal as before. You want to make sure you make good contact with it. Okay, same thing again. Looks like the exact same screw as the main chassis, which is convenient, not only for the manufacturer, but for us as well. So we don't have to keep up with two different screws, but also, it's cheaper for them to make it, easier for them to have a parts bin with just the same thing in it. Okay, and just to speed things up, I'll do this. So we've got all those out. That should be loose now. I hear a lot of rattling, so I'm going to be careful with this. Actually, I'm going to forget the towel for now. I'll lay this down. Pull this out. We'll look at this in a second. Oh, still got one loose guy in it. Pull this out. Put it over here. Whoa, there's a lot going on there. All right, so just like the back piece, this front piece is gray on the inside. It's got a silver sort of paint on the, I don't see too much going on. The screw holes are here. You can see the coarse threads in them. This is what would get screwed up again if you were to screw one of those screws in too tight. These buttons are really weird looking. They look like those little pads that would touch a conductive area on a circuit board, but they don't click. It's just a bit of rubber. And then when they're seated, they seat on these little tiny plastic pins. But there's not a lot of button travel there, so it's not going beyond the end of it. I mean, it's probably gonna be fun, but anyway. Black versions of the same thing. They're all just loose, just sitting in there. Same thing for these buttons. That's just like sort of molded shape. It's a little bigger. Same for this end. You got a big one here too. And then these are all clear cutouts here. You can see the glove. See my finger through there. Those are just clear cutouts for the lights. Okay, we'll put this to the side and try to not lose any of those buttons. And we'll check out what we got right here. Okay. These switches have this little pleather shroud here to keep dust out. Don't want to lose that. Don't want to lose that. Anything weird? I see in the light again. I see the sort of wash or lack of washing that's going on here. Interesting. It has. I mean, I guess it's just the flux that's left over and not washed off. I guess is what that is. There's a sticker here with an obscure code on it. 1948, so maybe the 48th week of 2019. I'm guessing. I'm not totally sure. So those black clips that are coming through the backside are these LED risers, and so instead of having the LED just come up on two leads that could easily be bent or whatever and have the LED itself stick through, the LED is actually inside of this. Could it be a surface mount LED? I guess it is. It must be a surface mount LED because I do not see leads coming through the other side. So there must be a surface mount LED under there, and then there's this fiber optic channel that brings the color up and makes it look like a little homogeneous light sticking through the shell. Our rubber bumper buttons push these little micro switches, but yeah, basically no travel there. I mean, I don't know what these are rated for, but I imagine it's measured in millions. You have to write a lot of really bad 16-step songs to ever wear one of these out. I think, you know, if you spill a soda on it or something, it might be a goner. There's no taking it apart. But in the meantime, those are pretty tough. That'll be all right. We've got a few ICs, capacitors. You see the microcontroller here. I'll get it closer to the camera. You see the microcontroller here. You can just tell based on how many pins it's got. I don't know what these ICs are here. I imagine this is part of the power section. They usually leave the power stuff, you know, close to the connector. These connectors, those are actually through connectors. That makes sense. It'd probably be hard to find a surface mount version of those. Okay, so yeah, a lot of analog circuitry going on here. I don't know. The audio path is probably not going through the microcontroller at all. I'm not really going to be able to analyze the audio circuitry here, but we'll take a look at the ICs just for fun. Let's see if we've got a slack on that. Let's see. HE466B. Let's see. It says it's a quad single pole throw analog switch. I don't know if that's where the square wave comes from. I'm showing my ignorance, but I don't know if this is the oscillator. Just based on the fact that it's got a QA mark on it, I feel like, and it's sort of an obscure chip, that this is probably the voice. That's probably what they're using for the oscillator, but I don't know for sure. This is over to the right. When you're looking at the front of the board, it says it's 74HC14D. 74HC14 hex inverting Schmidt trigger. Okay, also something that I've seen used as a voice. So I'm not sure. That could be the triangle wave, or I don't know. All right, we'll keep moving over to the right. Let's see what this is. 4580H6 8H6EJRC. Okay. Dual audio operational amplifier. All right, cool. So, yeah, probably part of the audio output circuit or part of the CV input output that, you know, we're right here next to that. 072C. Could be TL072C. I'm not sure, but it looks like it may be a JFET op amp. All right, we'll move on. 74HC595D. Similar to what we looked at before in terms of the number, but this is going to be 8-bit shift register. Okay, so it looks like there's 3 of these in a row here. Go back to the microscope. Looks like there's 3 of these in a row. And so this is going to be storing volatile memory essentially. So 8 bits, 8-bit shift register. This will be, you know, once you turn the unit off, this is not going to be storing anything. Let's see, there's 2 little chips down here too. 24256E S7N046. Okay, so here this is an EEPROM. This is probably storing, well, I don't know how much storage it has. 256 kilobytes. So this could be, very well could be all your melodies, tracks, and sequences stored there. Microcontroller's not going to have any, it may have some non-volatile storage, but considering how small it is, it probably doesn't have any non-volatile storage. There's another 595. So that's 4 shift registers. And then here finally is the microcontroller. Quite a small package. Looks like it says ARM. Yeah, it looks like it says ARM on the chip. I'm trying to focus that. GD32F35 something. All right. F35. We'll go over to the GD32F35. Okay. 350 it looks like probably. So this is IC15. Gigadevice, that's the GD32F, ARM Cortex M4. Interesting. I thought all of the GT32s were Cortex M3. I couldn't tell you the difference without looking it up, but see if we've got a visual confirmation here. Yeah, okay. This looks like we've got 16 pins down each side of an SMD chip, and it looks like, yeah, we can confirm by counting 1, 2, 3, 4, 1, 2, 3, 4. Oh, okay, this is actually a different package. That's 16 pin wide. Ah, here we go. Here's 12 pin wide version. So that makes sense. LQFP. Okay. C8, I see. Okay, yeah, so this is the F350C. 48 pin. All right. Look at these yet. This is another 4580. What was the 4580? I forget. Another dual, okay, audio operational amplifier. Okay. So that's 2 op amps in one package. You only need 1, obviously, for an audio circuit. Kind of in the correct direction. Okay. Looks like a 4580 and an LM358 Texas Instruments. I'm imagining that's another op amp circuit, but I don't know. Okay, so the LM58 X58 series, you got a 358 in is a whole series of more op amps. Awesome. Yeah, so like I said, there's a lot of analog circuitry going on here. The digital bits essentially are held in the shift registers and in the microcontroller. And then I saw we've got these film capacitors here, 124J63. I think I've got that pulled up somewhere. Similar to these, I'm not sure exactly what the voltage rating is, but it's a 0.12 microfarad capacitor. There's 2 of those. They stand out since they're like weird and yellow. And that's pretty much it. I think we looked at everything on the board. This, I imagine, is the clock signal. Something. Let's get a number off of that. Pine E49S8M. Let's look that up. Put the space in there. Here we go. Yeah, crystal oscillator, 8 megahertz. All right. Roaring. All right, that might be it. We'll put this back together. Here are the pots that we saw from the other side. VCA balance, VCF offset. Really nice that you don't have to take this little board off to get to those. You can do it from the other side. There's not really a lot of maintenance or adjustment that needs to go on this side. Yeah, I think that's about it. Okay, we'll try to get this back together. So I'll put this over it. You don't want to disturb any of those keys. And we'll try to just set this down into the place where it's supposed to go. Sort of just settle that down. Let's go through there. And that's pretty much it. One thing you want to be aware of is you don't want to get one of these switches loose, because they'll just come loose until they're being held down by the board. So now that they're being held down by the board, just most of the way, just kind of hold it in place. Just 2 for now, and we'll say, see how far that gets us. Looks like that's going to be pretty good. Just two setting is going to be plenty tight enough. And that way I'm not over tightening it. And again, you still want to have vertical pressure down into the screw to make sure that you don't start to slip in and strip out the top of the screw. Once we've got those in there, we just want to check this side, make sure that everything is coming through okay. All the switches didn't get jammed up or lost in there or anything. And that little footing goes in there. And that's it. We'll put the 8 screws back in. Okay, got 2 halves of the shell back together. And now we will put the knobs back on. Okay, and that's it. One thing I did forget to mention is that when we took these knobs off, we noticed that the resonance knob is different than the rest. It has that little notch in it. And if we look at the inside, that potentiometer is different. It has twice as many leads as the other potentiometers. I don't know if that means it has 2 signal paths going through it or what. Someone smarter than me probably knows. Another thing I noticed is under some of these knobs, you can kind of see the gray of the plastic coming through. You can kind of, it's interesting because you can kind of see the process that this piece is molded and then, like, I guess sprayed, because you can see like little splatter patterns on the inside of there of the silver. And of course you can't see it with the knob on. Plus, you know, these things are super cheap, arguably made under questionable circumstances. Nothing to complain about at all. Just interesting to see how they're put together. Overall, perfect unit. Does exactly what it's supposed to do. We'll see. If anybody has any, mechanical or otherwise any problems with it.